Today's session will cover congruency and how it's different to similar shapes, and also angles in parallel. The Heggerty clips have been set for you. Okay, so let's start with our retrieval practice. So give yourself 10 minutes, pause the video and have a go at these questions. Okay, so looking at the answers. The question's asking us to get the first number as part of the ratio to 1. So we've got 4 to 1. We need 4 to become 1. So 4 divided by 4 is 1. Whatever we do to one side of the ratio, we have to do to the other side of the ratio to simplify it. So there'll be 1 to a quarter. We do the same with 13 sevenths. We need to get 13 to 1, so it's 1 to n. So we divide both sides by 13. That's 1 to 7 over 13ths. Next question is asking you ratio of piece to farad is 5 to 12. So we know that's 12 parts. So writing piece as a fraction of a whole would be 5 over 12. Writing farad as a fraction of the whole would be 7 over 12. Bottom left-hand side is a pictogram. 20 of the students said yes. It gives you a key. It tells you what the key represents 5. So you just need to draw 2 more circles to say no for the 10 pupils who said no. The expression of the nth term for a sequence. So we're going from 13 to 10 to 7 to 4 to 1 to minus 2. So the difference between the numbers in the term-to-term difference is minus 3. So it becomes minus 3n. Now we know the first term is 13, so it's got to equal 13. So let's put 1, the first term, into our equation, into our nth term. So minus 3 times 1 is minus 3, plus something is going to equal 13. So that means the missing gap is going to be 16. Minus 3 plus 16 will give us 13. Does it work for the 10? Yeah. On the 7? Yeah. Right, we've got the number right. Okay, the final one from the starters today was coordinates. Now, our coordinate is only a coordinate. It's got the brackets around it, and it's got the x and y coordinate. Now, we always do the x, the horizontal first, and then we move and we look up on the y-axis. So we look at A, it's in brackets, it's a coordinate. We're going along the x-axis 1, and then we're going up the y-axis 3. So it's like going in your house, up in the house, and up the stairs. Okay, let's move on from there then. Today's lesson is to find unknown lengths and sides of similar shapes. So I need to explain the difference between similar shapes and congruent. So if we look at the first 2 triangles here, they are the same size, the same shape, the same side lengths, the same angles. They are classed as being congruent because they are the same. If we look at the triangles in the middle, they are also congruent. They are the same size, they are the same shape, same side length, same angles. They've just been reflected. So they're a mirror image of each other. If you look at the third set of triangles that we've got there, they are similar, but they are not congruent because they are not the same size. They may be the same shape, they may have the same angles, but they have a different size. So let's have a look at the angles in similar shapes. They're always equal. So the angles in similar shapes are always equal. These angles here at the top here, they are equal, but they're not congruent because their side lengths are not the same. Similar shapes are those which are enlargements of each other. So if we look at the triangles here, if we look at this triangle here and compare to this triangle here, if I multiplied and by a factor of 2, all the side lengths, 4.5 times 2 would give me 9. 3 times 2 would give me this side length, and 4.2 times 2 would give me 8.4. So these are similar shapes because they are enlargements of each other. Let's have a look at these then. It's asking us to find the unknown lengths. It's telling us in the diagram that this angle here is the same as this angle here. This has 3 lines, that has 3 lines. It's trying to tell us that these angles and these triangles are similar shapes. And it's telling us this also in the question by saying two similar triangles. It's asking us to calculate the side lengths of BC and also DF. So I'm looking at both triangles and I'm looking at the sides where I've got two sets of numbers. So AB, I have 8, and DE, I have 2. So if I do 8 divided by 2, my factor is 4. So DF is going to equal 10 divided by 4. Got to get smaller. And if we look at FE, so CB or BC, BC, okay, if we multiply that by 4, that's going to be the new side length of 12. 10 divided by 4 is 2.5. Have a go at the window. What is the factor there? Pause the video while you have a go. You're looking for the side X and Y, so that's BC and DE. Okay, we have 15 divided by 3, by 15 divided by 5. That's 3. Okay, so let's look at this one. So if we look at FE and we look at X, X is going to equal 5 times by 3, so that's 4.5. So this X is 4.5. Okay, DE is going to equal 12 divided by the factor of 3, so Y is going to equal 4. I bet you got that right. Okay, let's have a go at another couple. Okay, we're looking again. It's telling us there's two similar triangles. It's given us some side lengths. Okay, we've got 10 and 4.5, so the number that's in both of them on the same side. So our factor is going to be 10 divided by 4. Our factor is going to be 2.5. So 7.5 AC is going to be equal to 7.5 divided by 6.5. So AC is 3. DE is going to be 5 times 2.5. So that's going to equal 12.5. Pause the video while you have a go at the we do. Okay, two side lengths here that we can compare. So 4.5 divided by 3, 3 over 2 equals 1.5. Okay, so we need 12 divided by 1.5. I'm assuming you've got it, that's 8. And then we've got 5 times 5, 7.5. Pause the video if you need to copy any of those down. Okay. Another rule I need to get over to you is that two triangles are similar if the three angles are the same. So we know angles in a triangle add up to 180. So if I do 180 minus 70 minus 45, I'm going to get 65 degrees. So let's check this other triangle. 180 minus 5 minus 45 is going to give us. So these two triangles are not congruent, but they are similar because all three of their angles are the same. So the drawing beneath it, the purple triangles, this is trying to show that this angle is the same as this angle. This angle, same as this angle. Therefore, this angle will be the same as this angle. So we could work out a ratio, work out a factor between these two triangles, and therefore work out A, and we could work out B, as we've done before. So let's have a quick quiz then. It says, what is the size of the missing angle K on the larger triangle? Pause the video, have a think. What do you think it will be? Bear in mind that you can actually rotate the triangle round. Well done. That's 60, isn't it? So K is 60. Okay, here are two similar rectangles. Okay, what's the scale factor of enlargement? The factor. Have a think. Okay, you've got it? A, B, C, or D? Pause it if you haven't. Okay, 8 divided by 2, 4. Scale factor of enlargement is 4. It's asking what the scale factor of these two similar shapes are. So we've got 12, we've got 8. So 12, pause the video before I nearly gave you the answer. Okay, right. It's not going to be a subtraction. It's not going to be a multiplication. Okay, the only one it can be 12 divided by 8. Easy multiplication, 1.5. It's not going to be a recurring decimal. It's on a foundation paper, 1.5. Okay, let's have a look at this one then. It wants to know what the shape and the length, what the length is. Pause the video while you have a go at this question. Okay, I'm assuming you've started the video again. So you've got a scale factor of 3. 4 times 3 is 12. Well done. Shape on the right is enlargement. The shape on the left, what length should be replaced by the star? Pause the video, have a go. Bit of a trick question there, isn't it? Okay. Right, so 9 divided by 6 is 1.5. 12 divided by 1.5 is 8. So you could have had B and you could have had D there. Okay, have a go at these questions here. Pause the video and see what you can do. Okay, I think you probably worked most of those out now. Scale factor on A multiplied by 2. 8 times 2, 16. B. 5 times 5 to 15, scale factor 3. 4 times 3 is 12. Scale factor on 4. 12 divided by 4 is 3 centimetres. D. 15 divided by 2.5 is scale factor of 6. 1.5 times 6 is 9 centimetres. 12 and 60, 5, 9, 5, 45 centimetres. Next one, very, very, very careful with because you've got centimetres and metres. So I'll give you a couple of minutes to go back to that one again because you've got a metres in there that you need to be careful of. Okay, so the scale factor there is 20. So on the bottom one, 50 divided by 20 is going to be 2.5. Question 2. We can tell that these shapes are not similar because we look at the scale factor of 7 and 15. 7 multiplied is not going to be the same as 4, the scale factor. Scale factor for 4 and 8 is multiply. 4 times 2 is 8. 7 multiplied by 2 is going to give us 14, not 50. You could get questions like that on the exam. B, we've got 5 and the scale factor. Let's say it's 8. 5 times 8 is 40. Well, 3 times 8 is actually going to give us 24. So these cannot be similar shapes because the same scale factor will be used on each of the sides. So it's asking you to work out the size of EF, this size here. So 4 to 12, scale factor of 4, 6 times 4, 24. So what we've covered is congruency, where it has the same size angles and the same size shapes. And then we've also looked at similar shapes, and the difference between them is actually their enlargement. It's not the size of their angles stay the same. Be very careful on that when you're coming up in the exam. Okay, next we're moving on to applying some angle facts to some shape problems. We've got to be able to do these because you're going to get 4 or 5 marks on them, and you need to know these rules. Hence why I've added them to Hegarty this week. So we've got angles on a straight line adding up to 180. Angles around a point equaling 360. So A, B and C added together would give us 360. Vertically opposite angles, as in C and D, are vertically opposite. A and B are vertically opposite. We also have just used like angles straight line add up to 180. And the one you're probably not using that much at the moment is angles in any 4-sided shape will equal 360. Ones that you may not have seen before. These are alternate angles. Now, alternate angles, you can find them. I always start looking for the Z shape. You can't say Z shape on the exam paper. You've got to say alternate angles are equal. So if this angle here for 5, sorry, this angle here has to be 5. These are corresponding. So go on to the second one over here. Corresponding angles. I always look at this one with tracing paper. So I'll put if I was in the exam, I'd put my tracing paper over that angle, and then I'd move my tracing paper down to find out if this was in the same shape. And because there's parallel lines, it means that parallel line means there's 2 lines that are the same distance apart from each other and they never touch. Okay, so A and B are definitely corresponding angles. So if A was 100, then B would be 100 degrees, both 100 degrees. Okay, you could say they look like they're in an F shape, but an F shape would not get you the mark in the exam. You have to say they're corresponding. The next ones are co-interior angles. I look at that as like you and your best mate, and you're sitting on the settee together. So if you look at them both here, you can see it's like you're cuddled up together on the settee. Now we say co-interior angles, they add up to 180. So if X 60, then Y has got to be 120. So 60 plus 120 equals 180. Okay, so we're going to apply those rules now to these facts. So if you haven't written them down, go back, pause it, go back and write down those angles. That's really going to help you with these examples. And I do want you to have a go. It's asking me now to find the missing angle or give a reason. Okay, so it wants me to find out this angle here and then this angle here. Okay, I've got 2 parallel lines going across. I've got a parallel line going across here, and another parallel line going across here, which means there's a relationship between this angle here and this angle here. Now these are alternate angles. So I know they are alternate angles, and I know alternate angles are. So if G is 5 degrees, then C angle, angle at the H angle has got to be 125. Now, if I was in an exam, I wouldn't label it like that. Okay, I would write alternate angles are equal. Okay, I know where I'd get them. Draw an angle that I'd write 125. I know that's an alternate angle. But I'm going to look at the other one as well. So going down here, I can see it's alternate angle. It's going one way than the other. So this is also an alternate angle of 110 degrees. Let's look at angle HGM. If you look at HGM, what do they mean by HGM? Well, HGM means that the angle is at G. Okay, it's the middle letter. Sometimes it's written as HGM with a little hat over the G to say what the angle is. So it's asking for this angle here. It wants to know what this angle here is. I can see, again, I've got an alternate angle, which is what you've probably done, seen the alternate angle. So if this one is 135, then this one here has got to be 135. And I would have to write to get the mark alternate angles are equal. I don't write that, I'm going to mark. Okay, let's look at the other one then. I've got 120 down here. Means this one here up here has got to be an alternate angle. 120, let's follow the shape and check. Yep, that's definitely 120 degrees. Okay. Sorry. Okay, let's have a look at these ones. These are corresponding angles. Corresponding. Okay, think about what corresponding means. Tracing paper. In the exam. So I've got 55 down the bottom here. If I was to get my tracing paper and push it up, okay, because we've got parallel lines going across here, they don't ever touch, okay, in the same distance apart from each other. So I'm now looking at this. If angle F is 55, then this angle here is 55 degrees. I would have to write corresponding angles are equal. Okay, pause the video while you find me angle CHF. So, okay, and you find me angle BGN, angle G. Can you tell me what those are? And I know, of course, you're going to write me corresponding angles are equal. Pause the video then, please. Okay, so if G is 50, then H has got to be 50 degrees. If N is 70, then the angle at that point there has got to be 70 degrees. Well done. Okay, and there's a long hand of explaining. You can pause that video and pause this and have a look at the answers. That's a long way of writing it out, but you would have to write corresponding to get the mark. Okay, finally, co-interior, you and your mate on the settee. Now, co-interior angles, so we'll write that down there on the interior angles degrees. Okay, so I'm looking at this angle here, and I'm looking at this angle here. So let's add them together. We know they're going to equal 180. If I do 180 minus 45, I'm going to find the angle. So 180 minus 45 is 135 degrees. So this angle here is 135 degrees. If you label that, then the examiner will give you the mark for it. So pause the video and have a go at the we do. Okay, here we go then. So 180 minus 120 degrees. Label the angle. Tell me that is 50 degrees. Okay, and get the mark. Sorry, my pen's not working very well this evening. Okay, and there's the answers for that one, just to make sure we've got them right. Okay, right, pause the video while you have a go at these questions. Be very careful on D, E, and F. Okay, let's go through the answers then. Okay, these have been written out longhand. So check what you've done on your sketch drawings. What did you get? Okay, and the first three, of course, were corresponding angles. All three of them were corresponding angles, the tracing paper ones. The second ones are the problem solving. Now I'm just touching on these because I want you to think about doing this. And then later on before the exam, I'll make sure that we go through these and we do a lot more problem solving so you're working between all of them. If you've got some of these correct, then well done. Very impressed. If you've got all of them correct, I'm ecstatic. Okay, you'll do well. If they were to come up in the exam, you do really, really well. Well, that's the end of the session today. I hope you've had a good lesson. Sorry if you couldn't make it at the time. Okay, bye. Have a nice day.